Welcome, everyone, to today's episode on why multi-agent LLM systems fail and what we can learn to build them better. I'm thrilled to have 5 experts here, each bringing a unique perspective. Let's kick things off with a quick round of introductions.
Thanks for having me. I'm mainly focused on the business and strategic side, how these multi-agent systems can truly impact organizational strategy and ROI.
Delighted to be here. I specialize in the technical design of AI workflows, especially large language model orchestration.
Hey all, I'm a researcher in AI alignment, so I'll dive deep into why these agents miscommunicate and how to fix it.
Great to join you. I've worked extensively on multi-agent verification protocols, making sure these systems actually generate correct outputs.
Hello, everyone. I look at the broader business applications, product launches, marketing relevance, and how to leverage these technologies at scale without losing sight of profitability.
Fantastic. So the big question, why do multi-agent LLM systems, which sound so promising, often fail? Expert 2, maybe you can start us off with the key failure categories that keep popping up.
Absolutely. We've seen they typically fall under 3 main categories. First is specification and system design, unclear prompts, missing constraints, or contradictory instructions. Then there's inter-agent misalignment, where agents don't communicate effectively or even ignore each other's inputs. And finally, there's task verification and termination, where the system either ends too soon or lacks solid checks to catch errors.
I find that second category, inter-agent misalignment, especially fascinating from a business standpoint. If you think of each agent as a department in an organization, it's like your marketing department never speaking to R&D. As Tolstoy might say, each failing system has its own problems, and we certainly see that here.
Right. And these issues aren't limited to niche tasks. Even big software development workflows fall victim. I saw a multi-agent coding tool that was supposed to handle everything from design to testing, and half the time, the testing agent never received the correct input from the design agent. It's like building a car with no blueprint shared across the assembly line.
And that's a great analogy. In one scenario, the verifier agent just rubber-stamped the final code without truly running quality checks. So the mission-critical question is, how do we ensure that you don't skip that last step, especially when the system's moving so fast?
It reminds me of a real-world case in retail. A company wanted a multi-agent system to handle inventory management, sales forecasting, and marketing promotions all in parallel. But the forecasting agent never validated data from the inventory agent, so they ended up overselling on a special promotion. They had to apologize to customers and lost 10% of projected holiday revenue. That's a big strategic fail.
Ouch, that's painful. Expert 2, you mentioned specification and system design. Can you elaborate on a technical fix for that category?
Sure. One approach is clearly specifying each agent's role in prompts, what problem context it holds, what it's responsible for, and crucially, what it must not do. Then we define how the conversation flows. For instance, a manager agent orchestrates tasks, and only that manager can finalize the conversation. It's a bit like a chain of command.
Precisely. And we can formalize it with conversation patterns like star or hierarchical orchestration. Each agent has to confirm it understood the last message, like a pilot reading back an air traffic controller's instructions. That can mitigate misunderstandings.
Another angle is explicit memory. If you have a memory store or a state manager that logs key steps, you reduce the risk of the system forgetting information. But it does take more overhead and often careful prompt engineering, especially if the conversation gets long.
And from a business leader's perspective, that overhead is worth it if it prevents costly mistakes, especially in industries like healthcare or finance. You can't afford a meltdown just because one agent missed a detail in the conversation.
We've touched on design and misalignment. Let's talk about task verification and termination. Expert 4, you're the specialist in multi-agent verification. Any best practices?
Well, one technique is to have not just a single verifier, but multiple specialized checks. Think of it as a layered defense: a code verifier agent, a compliance verifier agent, and maybe a domain verifier agent. Each focuses on a different aspect. So if you're writing code, the code verifier checks for syntax and logical errors. The compliance verifier ensures we're not violating regulations or guidelines. And the domain verifier sees if we're actually satisfying the business logic. That last layer is crucial.
And if each verifier simply says, everything's okay, let's move on, you get no improvement. They need the capacity and the authority to request modifications or reject the final product. That's often overlooked.
Exactly. There's also a method called LLM as a judge, where an external model is used to evaluate the conversation trace. This judge model checks for potential hallucinations and logic gaps. Even that is not foolproof, but with some prompting finesse, it's surprisingly robust.
That's interesting from a strategic vantage point. You could see it as setting up a board of advisors for the system, different stakeholders each with veto power. However, you've got to watch out for bottlenecks. If you get too many layers, your time to market might explode.
Right, it's about balancing thoroughness with agility. Let's pivot to the real-world domain again. Expert 5, you mentioned a retail example. Do you have another business scenario where multi-agent LLMs excel or fail?
One standout example is in pharmaceuticals. A firm used a multi-agent LLM pipeline to propose new molecular structures, cross-check potential side effects, and generate documentation. It saved them months. However, one time, the cross-check agent didn't actually confirm dosage consistency, and it proposed an unrealistic regimen. Thankfully, a human team caught it, but that near miss revealed just how critical robust verification is.
And in line with that, you add a safety agent specifically for dosage checks. Then you have a well-defined protocol. The design agent proposes, the safety agent reviews, the verifier agent cross-checks everything, and only then do you finalize. It's that discipline that prevents catastrophic missteps. Yes, it's basically the 80-20 rule. 80% of the problems can be avoided by 20% of the best designed processes, like clear role constraints and a thorough verification loop.
But watch out for the minority of edge cases. If you're in a domain like finance with complex regulations, your system might pass 95% of normal tasks and fail spectacularly on corner cases, like generating a compliance breach. So you need reasoned coverage of those extremes too.
Let's add a bit of humor here. Expert 5, could we solve all these corner cases simply by throwing more agents at it? Like hire an agent for every letter of the alphabet?
Ha! That might be the biggest too many cooks in the kitchen scenario. You'd likely create more chaos than clarity. So no, I wouldn't recommend that unless we want an AI version of a clown car.
Right. From a management perspective, giving each agent a single job is wise. But if we spawn 26 agents, we risk more misalignments. It's that sweet spot. Enough specialized roles to catch errors, but not so many that the lines of communication become a spaghetti mess.
Let me jump in on the contrarian side. Everyone's pushing for agent orchestration, but I think we're sometimes missing better single-agent baseline solutions. If a single powerful agent with a structured prompt can do the job reliably, that might be cheaper and simpler. We often rush into multi-agent setups without evaluating whether we need them in the first place.
Interesting point. Sometimes a single agent with iterative prompting outperforms a multi-agent system that's poorly orchestrated. But if the task is truly modular, like generation plus critique plus domain checks, an ensemble can be more consistent, provided it's managed well.
So maybe the future is something in between, like a small team of specialized agents plus a robust manager agent built on a well-defined architecture. Expert 2, how do you see the next wave of solutions?
I see more standardized frameworks, like plug-and-play modules for memory, for domain checking, for partial code generation. Then system designers can easily adapt the pipeline to their domain. We'll also see better fine-tuning for each specialized agent, making them more consistent.
And from a strategic lens, we'll see more cross-industry adoption. It's not just coding. Think HR queries, complex scheduling, supply chain analytics. If we nail the specification category from day one, we can avoid the main pitfalls, and that'll definitely pay off in the long run.
Absolutely. I predict that forward-looking businesses will trial these multi-agent systems for tasks like handling customer support across multiple channels, but they must create good feedback loops, both automated and human-validated, so that misguided responses don't slip through and tarnish brand reputation.
Terrific insights. Let's wrap with a quick heuristic you'd each give our listeners. Let's do a lightning round.
My heuristic: trust but verify, and then verify some more. Don't rely on a single check.
I'd say scale only after you nail the fundamentals of role clarity and conversation structure. If your verifier can't catch it, your system will ship it. Make sure your verification is rigorous.
Pick the right tasks for multi-agent solutions. Don't just use them because they're hype.
And I'll say organizations are like multi-agent systems. Alignment and clarity rule the day.
That's a great note to end on. Thank you all for a wonderfully lively and deeply insightful conversation. To our listeners, if you're building or considering building a multi-agent LLM solution, remember these best practices and cautionary tales. Until next time, take care. Well, it seems we still have some fuel in the tank, so let's jump right into part 2 of our discussion. I'd love to dig deeper into the actual technical implementation details for multi-agent systems and then explore some broader business use cases. Ready to roll?
Absolutely. Let's begin with implementation specifics. One question I often hear from C-level executives is, okay, theoretically this sounds great, but how do I actually deploy a multi-agent system in my existing workflows? So maybe we can start with how we practically design these agent roles and orchestrations.
Sure thing. At the most basic level, you might have a central orchestrator agent that handles role assignments, like Agent A is the data collector, Agent B is the analyzer, and so on. Technically, you could store an explicit role description in each agent's prompt. Then you run a loop where the orchestrator passes tasks, listens for each agent's response, and logs them into a shared memory buffer.
Right. A robust memory buffer is crucial. One approach is to store all relevant conversation snippets in a vector database or a structured store. Each agent can query it when needed. This reduces the history forgetting problem, a common culprit for misalignment. It's a bit like everyone on the team referencing the same project management board, so no one misses a critical update.
And to confirm, you'd have logic in the orchestrator that says, if agent X or Y detects a contradiction, raise a flag. That logic can be codified, which is basically a set of if-then rules. Some folks even incorporate a small state machine, so you meticulously manage who speaks, what's being said, and when to finalize. That aligns with the concept of blocking calls or gating steps in software engineering.
From a business standpoint, a lot of leaders worry about overhead. Does all this back and forth slow us down or add cost? But we've actually seen that if you do it right, you cut expensive human QA time drastically. One enterprise case I heard about reduced their bug fix cycle by 30% because the multi-agent system flagged issues earlier.
That example is great, Expert 5. Now I want a deeper technical nugget. How do we handle the actual text passing between agents? Expert 2, do we just do normal LLM calls?
Typically, yes. For each turn, you construct a prompt that includes some critical context from the memory buffer plus the agent's role instructions. Then you call the underlying LLM, say GPT-4 or whichever model you have. It's expensive if you have 10 or 12 agents chatting away, so you might do fewer roles or run them sequentially, depending on your needs.
Another advanced technique is partial token generation, where you selectively pass only the relevant snippet to each agent. This is trickier, but can prevent side-channel chaos. It's like giving each department only the data they truly need to see, rather than the entire company's secrets.
Let's also talk about verification agents. Technically, the verification agent might run additional code or use a zero-shot chain-of-thought approach to note inconsistencies. Or it might do actual test execution if your domain is code. We've even seen specialized symbolic logic verifiers that parse the conversation to see if the statements are logically consistent.
That's where real business value emerges. Think about a financial institution that's auditing loan approvals. One agent might propose a conclusion, loan approved. Another agent checks compliance. And a verifier agent runs a risk assessment. If something's off, the conversation doesn't move to final approval state. That alone can prevent regulatory disasters.
Fascinating. I'd love an analogy or two. Expert 1. Do we have a good one for explaining these multi-agent orchestrations to non-technical executives?
Imagine you're running a big sports team. Each player has a specialized position: striker, midfielder, goalie. You also have a coach orchestrating who needs the ball, who should pass, and when to shoot. The players can talk among themselves, but the coach ultimately decides the formation and ensures the team doesn't, say, leave the goal empty. The fans in the stands might be the verifier agents, shouting if someone is offside or if the referee missed a foul. That's basically how your multi-agent system might work. Everyone has a job, but they need rules, roles, and a trusted orchestrator.
Ha! I love that. And to build on it, if one player tries to do everyone else's job, like a striker who wants to be goalie, that's a design failure. That's why specifying roles carefully is so crucial. It prevents duplication or chaos.
That's a very helpful analogy. Now let's frame a second business scenario to show how it unfolds in practice. Maybe something outside of software coding. Expert 5, you mentioned HR or customer service.
Right, let's pick customer service. Imagine a telecom company that gets loads of billing inquiries, technical troubleshooting, and new subscription requests. One agent's job is triage, deciding if the incoming query is a simple billing question or a complex network support issue. That agent forwards the question to the specialized agent, say a troubleshooting agent, who checks common solutions. Meanwhile, a compliance agent ensures no personal data is revealed incorrectly. At the end, a supervisor agent verifies if the user's question was met. Only then is the conversation closed. This multiplies productivity because humans handle only the escalated or unusual cases.
And from a technical perspective, that requires robust classification prompts, plus well-defined conversation transitions. If the triage agent is uncertain, it might ask clarifying questions, like a nurse at the front desk clarifying your symptoms. Once sure, it routes you to the right specialist.
I see a potential hidden benefit: granular metrics. You could measure exactly where the conversation faced friction, which agent had to escalate, or how many times a compliance check was triggered. For business leaders, that's gold. You can iterate and refine the system to reduce friction and keep the brand experience top-notch. People love quick solutions, right?
Absolutely. Behind the scenes, that means you're orchestrating effectively. Some frameworks do it with a central pipeline, others with a star topology, like the triage agent in the middle, specialized agents around it. The choice depends on your domain. Technically, you might implement that in Python with a library like FastAPI, each agent run in a microservice or container. The memory store might be a Redis queue or a modern vector store for shared embeddings.
Let's talk about potential gotchas. Expert 4, what if the system runs indefinitely or keeps looping without concluding?
Then you need a termination policy. One method is a maximum turn cutoff, like after n interactions, the manager or orchestrator forcibly ends. Another approach is a termination condition agent that monitors the conversation, checking if the final answer meets all specs. If not, it stays active. If yes, it signals a graceful shutdown. Think of it as the referee who calls the end of the match. No more extra time.
We've also seen a simpler approach. Let the manager or orchestrator agent be the only one who can declare end of task. Meanwhile, the other agents can only propose, "We think we're done." The orchestrator decides. This ensures accountability.
And from a budget standpoint, you definitely want a termination policy so you're not racking up huge API costs. Imagine if your analysis agent keeps rechecking the same database. That's an expensive infinite loop.
This is where we can add a bit of humor. I once saw a multi-agent config that chatted for 57 minutes about how to alphabetize its own logs. That was the biggest nothing burger of a conversation I've witnessed. But wow, what a cost to the dev team's test budget.
Definitely not the best use of corporate funds. Now, let's say we've hammered out a well-structured system. Expert 2, how do we measure success?
I'd suggest a two-step approach. 1. Define a set of tasks each specialized agent should handle, like test-driven development, but for multi-agent roles. Then measure success rates, correctness, and the number of conversation turns needed. 2. Evaluate real-world scenario performance, like time saved, cost reductions, or user satisfaction. A classic example is the reduce by 15% support calls objective. If the system delivers that, we know it's successful.
Agreed. And you can add a final step, run a robust stress test. You feed ambiguous or contradictory queries, or you deliberately not provide necessary data to see if the system gracefully fails or loops forever. That stress test reveals a lot about potential real-world fail states.
Excellent. Let's shift to the big picture. What future developments can we expect? Are we heading to an era of 30 specialized agents, or eventually back to single agent plus a robust verification module?
Strategically, I think an equilibrium emerges. Some tasks, like writing a short email, barely need multi-agent logic. Others, like orchestrating a massive drug discovery pipeline, benefit from multiple specialized roles, so it'll be domain-dependent. Meanwhile, we'll see frameworks that make multi-agent setups more plug-and-play.
I foresee more synergy between multi-agent systems and existing organizational processes. For instance, agents that can automatically update your project management software, raise a ticket for DevOps, or trigger a new marketing campaign. That's even more ROI friendly because it bridges the gap between AI and standard business tools.
And on the alignment side, we'll see better policies to ensure these agents act ethically and remain safe. If each agent has a specialized domain, the risk of a single widespread hallucination is lower. So ironically, multi-agent systems can be safer than a monolithic agent, as long as you design them well.
Great. Before we sign off, maybe each of you can give one parting thought about the next steps for an organization that wants to implement a multi-agent LLM system. Let's keep it succinct and practical.
Start small. Build a minimal scenario with 2 or 3 agents, like creation and verification. Prove it works, then expand.
Document everything. A multi-agent system is only as strong as its spec. Ensure you have clear role definitions and keep them updated.
Don't neglect verification. Build it into your pipeline from day one rather than slapping it on later.
Tackle a real business pain point. Show ROI early. That helps with stakeholder buy-in.
Make sure you ring-fence your resources for iterative improvements. These systems evolve as your business does. Keep measuring performance and refining.
That's a fantastic set of insights, concise and to the point. Thank you all for sticking around for part 2 of our deep dive. We've covered everything from memory buffers to business ROI. We hope we've enlightened both tech leaders itching for specs and business leaders hungry for competitive advantage. Thanks for tuning in, everyone. Until next time, take care.